My name is Ralf Grassnick. I'm responsible for electrics, electronics, and BMW in China. And let's recap one of the scenes in the movie clip we saw. A couple is stepping into their car late at night in Shanghai. The city is alive, lights reflecting on streets, traffic flowing in every direction, millions of decisions happening in every second. And yet inside the vehicle, there's a different feeling: calm, trust, and anticipation. The car does not feel like a machine alone anymore. It feels aware, it understands the road, supports the driver, connects seamlessly to the digital world, and turns complexity into confidence. The moment is powerful because what our industry is really building, we are not developing cars, we are creating intelligent companions for a new era of mobility. Vehicles shaped as much by software as steel, design, or horsepower. And nowhere is this transformation more exciting than here in China, where customer expectations for digital experiences, intelligent assistant, and seamless connectivity are redefining the future of mobility at extraordinary speed. For an audience like this one, passionate about both the automobile and the software behind it, this question is no longer whether software matters. The question is, how do we build the right foundation for it? This is where AUTOSAR comes so important, because if the future vehicle is defined by software, then software needs a common language, a scalable architecture, and trusted collaboration across the industry. As core member of AUTOSAR, BMW sees this not as a technical necessity, but as a strategic responsibility. The architectures we define together will shape how future vehicle will be built, how they evolve, and how they deliver safe, intelligent, and emotional, compelling experience to customers. So today, I would like to tell you a story about more than technology. It's a story about how E/E architecture becomes an enabler of emotion, innovation, and trust, and how together we can build a software-defined vehicle for the next generation of drivers. So let's have a look on the technical complexity needs to be mastered beneath the surface. The design objectives behind the E/E architecture. Complexity management. Reducing variations through consolidation, standardization, and clear ownership. Scalability. So one architecture can support different vehicle segments, the needs of China and other markets, and global legal requirements without constant redesign. Safety and security. Building in fail operational behavior and secure communication from the start. And last but not least, life cycle and brand attributes, ensuring efficient manufacturing, long-term maintainability, and the premium brand experience over time. So for software-defined vehicles and in the future AI-defined vehicles, none of this works in isolation. It depends on strong collaboration, and that is where AUTOSAR provides a critical common foundation. This slide shows the current available generation of the market, designed in 2021, represented here by the wiring harness impression of the current BMW i5. It's a useful reference point because zonal architecture, as we heard beforehand, plays a major role in understanding the next step in the evolution of the vehicle architecture. And now, by comparison, let's have a look on the wiring harness of the Neue Klasse. This picture makes the transition tangible in the vehicle itself. We are now looking at the wiring harness of the Neue Klasse. Zonal architecture is no longer just a software concept or an E/E diagram. It is becoming physically visible in the car. The Neue Klasse harness shows a much more radical, simplified, and zonal approach that matters for us in AUTOSAR context, because this kind of architecture supports scalability, reduces physical and logical complexity, and creates a stronger foundation for software to evolve across functions, domains, and all vehicle lines. And this is where Neue-Klasse comparison becomes visible in a very concrete way. So what looks like an architectural decision on paper, central performance compute together with full zonalization, translates directly into less complexity, lower weight, fewer variants, and better efficiency. So for us, software-defined architecture is not an abstract IT concept anymore. It becomes a hardware foundation that improves the car in measurable industrial trends. At the center of the shift from distributed complexity to centralized compute and zonal architecture, performance compute together in 4 superbrains in co-location. This matters because software-defined vehicles need more than compute power alone. They need an architecture that is efficient, upgradable, and ready to evolve over time. They need an architecture that is efficient, upgradable, and, as I said, to evolve. That is why one important design principle here is physical headroom for future hardware upgrades. In other words, the architecture is not only designed for today's functions, but also for what will follow into the vehicle over the coming years. The same logic applies to the electrical system. Even with the much computing capabilities, the total vehicle electrical system power consumption stays below 400 watts. That is a strong signal that centralization is not creating overhead, but actually improving efficiency. And when we see the second major effect, the zonal wiring harness, by moving to a 4-zone architecture, complexity is reduced dramatically. The wiring harness becomes around 30% lighter, and the number of variants is reduced by a factor of 3,000. That is not only a technical improvement, it's a major industrial advantage. Finally, this architecture also enables automated production of the zonal-related sub-harness, so the benefit is not limited to engineering, it extends to manufacturing, scalability, and speed. And that is why this slide is so important. It shows that zonal architecture is not just a design trend. It is a practical foundation for making the software-defined vehicle more efficient, more adaptable, and more future-ready. If we now look at the zonal architecture through that lens, the ECU landscape can cluster it into 3 categories: central performance compute, zonal compute, and the peripheral ECUs. The most important point is where the software concentration sits. Around 90% of the vehicle software is located in the superbrains, the central performance compute, because that is where the major functions, coordination logic, and continuous feature evaluation are concentrated. And as functional is increasing, the share of in-house development also rises. In the periphery, components are typically bought to specification, highly optimized, clearly defined, and sourced efficiently from suppliers. But as we move toward the superbrains, BMW takes a much more make role. That means we develop a large share of the software ourselves, or we work very closely with partners in true co-development, where the architecture, interfaces, and core capabilities are shaped together. At the same time, we are very clearly that this does not mean coding every single line alone. From both an engineering and economic perspective, that would simply make no sense. The value comes from owning the right software layers, controlling the system architecture, and integrating the vehicle as a coherent software platform. This is where the software-defined vehicle really comes to life. Through a chip-to-cloud architecture that connects hardware, middleware, shared services, and applications into one scalable system. And for the Neue Klasse, the important point is that BMW did not have to reinvent the wheel. We could build strongly on software platforms and capability that already exist and have already proven themselves. In infotainment, for example, the BMW operating system is already AOC based. In the shared service layer, many elements are now new inventions either. But further evaluations of capabilities we already know well. So, such as over-the-air updates and data management. And one important clarification of the hardware side, the visual may say at a first glance, it looks like a classic domain architecture. But that's not the right interpretation. These high-performance compute takes a leading role for their responsible domains, for sure, while at the same time handling many cross-domain operations as part of the integrated platform. That combination of continuity and evolution is what makes the Neue Klasse architecture so powerful. It is ambitious, but it is also grounded in a strong software and technology foundation built over previous generations. And this brings us to scalability. What you see here is one architecture that can flex across both drivetrain types, vehicle segments, from ICE to PHEV, to PHEV and BEV and FCEV, and from compact vehicles to luxury. For us, that's the real value of software-defined architecture, not creating separate technical words for each product, but building one common foundation that can be reused, adapted, and scaled efficiently across the full BMW portfolio. In the next step, that common foundation also becomes the basis for a faster rollout and long-term compatibility. And this is where the architecture turns into a real product advantage. Because we have industrialized these technology clusters, BMW can roll out them with much greater speed across the portfolio, while also maintaining backwards compatibility. That means the very first vehicle of the Neue Klasse are already benefits from improvements and updates that arrive later for the vehicles that follow. So this is not just a faster launch sequence, it is software-defined foundation that keeps creating value over time. And that naturally leads us to the next step in the story, how we scale this platform for the future even further. So if we now make the concrete, this is what industrialization looks like at a scale. BMW already operates the largest OTA fleet across all key functional domains, across all powertrains, and across more than 60 models and 3 brands. That matters because software-defined vehicles is not future promise for us. It is already a production capability. Installation process over the air in 20 minutes is benchmark. And the strategic point is the platform leverage. Every upgrade, every quality improvement, every deployment process strengthens the whole system. This is exactly the foundation we need as we move next to China-specific collaboration and ecosystem integration. And this is what comes next. This brings us naturally to China. The same software-defined architecture is what prepares BMW to work deeply with Chinese-specific intelligent driving partners and digital ecosystems. It gives us a stable core while still allowing local innovation where it matters most for customers here. So this is not just about technical integration, it is about creating an ecosystem experience that feels truly relevant in China without compromising the consistency, safety, and architectural discipline of over-the-all BMW platforms. And this is obviously I had a screen here. Yeah, now it's good. Okay. And this is where that architecture, very tangible, is for China. With Momentum, we combined BMW's safe, smart, and symbiotic ADAS philosophy with a locally trained AI stack. So the vehicle can deliver navigation guided assist and guided level 2++. In a way that fits the local traffic environment and user expectations. For us, this is not a deviation from the architecture story, it is a proof point that a strong software and compute foundation lets BMW integrate the right ecosystem partners while still delivering one consistent product experience. And this brings us to the broader implication of software-defined mobility. Software does not scale with a hero project. It scales with architecture. What you see here is a four-fold increase in software build output within 5 years. And that is a very strong signal that the software factory behind the vehicle is becoming as important as a vehicle architecture itself. For BMW, as a core member of AUTOSAR, this is part of the long-term roadmap. Building a platform that can absorb growing software complexity, give fast feedback to developers, and continuously deliver value into the car over time. In the next slide, I will close this sequence by showing the architecture is not only inside the car, but also inside the development toolchain that makes this scale possible. It brings us to the final point in this sequence. Architecture is not only something we design inside the car, it is also something we build into the development environment behind the car. What you see here are the software output performance figures today. More than 30,000 users, over 1,000 software components, around 200,000 software builds per day. And feedback from a software change to a final build in about 15 minutes. For us, this is what industrialized software really means. Massive scale, fast feedback, and a tool chain that can support the speed, the quality for the software-defined vehicle. As we close, I would like to return for a moment in our opening image. A couple is stepping into their car late at night in Shanghai. That simple moment is what all of this work is ultimately about. From architecture to implementation, the journey leads us to one clear insight: no company can build a software-defined vehicle alone. That is why collaboration must become practical. Standardization gives us a shared foundation. Tooling makes the complexity manageable across all architecture and compute platforms. A strong ecosystem brings OEMs, tier ones, semiconductor partners, and software vendors together. And China focus ensures that global platforms are shaped with the speed, expectation, and innovation of the China market in mind. As a core member of AUTOSAR, BMW is committed to helping driving this work forward. Not alone, but together with all of you. Software-defined vehicles require deep collaboration, and AUTOSAR provides an essential standardization layer for this new era. If we build on trust, if we keep innovating, if we collaborate with real openness, then together we can create the next generation of software-defined vehicles. Vehicles that are not only smarter, but better for the people who will rely on them every day. Thank you.
Okay, this leaves the time for some questions. Thank you. Any questions from the audience?
A lot of questions, obviously, in that area.
I'm a bit embarrassed though. Thank you for the great presentation. Just one question. It was really interesting. You're talking about standardization of the platform. So using Neue Klasse, you have released in Europe and you have released in China. My question is, of course, we know you have a different ecosystem in China. So, for example, you're using ADAS and with Qualcomm in Europe, and now you're using Momenta for China. So, my question is: have you reached a level of standardization in your architecture that you can sort of plug and play different hardware and software platforms from different domains? And second question, I just wanted to confirm if it is indeed part of the plan to transition ICE vehicles and hybrid vehicles into the Neue class of zonal architecture.
Yeah, thank you for the questions. Let me take the first question. The platforms are generally the same hardware. This is what ensures that we can integrate very easily, very flexible partner solutions. And this is where the flexible architecture comes into account. This is where software easily could be transformed, easily could be implemented. For Momenta, we use the same hardware as we use for the European system, or worldwide system, let's say. And this hardware platform is based on the central architecture. As I showed a little bit about these flexibility in the peripheral components. Now, the central compute is still remaining the same. It is about the peripheral, where we have to adapt a bit, but generally there's only a new algorithm running on the same machine. The second point, when we are talking about Neue Klasse, this is fully electric, to make that clear. But we have a lineup that relies and can profit from the Neue Klasse experiences. That means ICE vehicles, PHEVs. They are profiting from the Neue Klasse general approaches, but they are not Neue Klasse. To make this clear, Neue Klasse is fully electric. But it makes the possibility to take advantage of all what we develop for Neue Klasse, especially when it comes to algorithms. Thank you.
There was a second question right next to. Yeah.
Or a third one even.
Hi, my name is Chris. I'm also an analyst from Omdia. I have a very similar question when it comes to BMW iX3. So I was wondering if it's still going to be the same vendors and partnerships when it comes to some of the companies that you mentioned, Momenta, DeepSeek, to outside China market. And also, could you share some of your experiences managing and working with different engineering and software teams when it comes to deploying different technologies to different countries and markets? Thank you.
Yeah, thank you for the question. Yes, it is about, as I said, it's about standardization. If you can rely on standardization, it's easy to shift all that information to a new partner. For sure, you have to integrate the partner. Newly, it was a lot of effort for both sides when we collaborated and started with the Momenta, but it's a very fruitful collaboration because it is based on the same understanding for the hardware level, and this is where the software standardization comes into account as well. Now we take the same basis. Generally, we have the same connectivity, and we use the same approach for standardized software. This is easy approach worldwide, but we need to rely on the partners. As I showed in one of the slides beforehand, AUTOSAR is very important for all of the components, especially in the periphery. You need to standardize the periphery, then you can own your own controlling on your own code, but you can implement in the same time, you can implement partner solutions very well. This is based on standardization because that needs standardization to hold the speed and development that's needed. Thank you for the question.
Any more question in the room? If not, you still can take time, but I will ask a question actually. I saw the 3000 factor complexity reduction which is quite impressive. And I assume some of it is a reduction of ECUs. Can you highlight maybe how much the zonal central architecture has led to reduction in ECUs? So what was the starting point and where did you end up and how much was it reduced?
Yeah, thank you for the question. Yes, if we look on the i5 from 2021 as a comparison, now we are talking about 70 to 80 ECUs in the car. Then we reduce this for the four zones and the four superbrains down. If we take into account link components as well, yeah, the small and tiny components, we reduce it by a factor of 3. That means we still have 25 to 30 components in the car, depends on the equipment, depends on the options, but we could reduce it. But especially this wiring harness reduction, the complexity of 3000 is simply to scale up if you have to consider the wiring harness combinations you have normally in options. And BMW is known for a lot of options. You can choose more or less each and everything in combination. That's why it scales up to 3000.
But does this mean then, like typically you have to trade off silicon versus harness, but in some cases, if the actuators are far away, you have to compensate with harness. So sometimes you end up like with very big plugs and cable bundles. So how was this solved then?
Yeah, that's a good point. Actually, if you have a look on the same sensor equipment, it is still solved by some smaller components like link components, for instance. But if you have a look on the zones, you can directly reduce wiring harness lengths. Because normally you put all the sensors, if you think about 11V system, for instance, with 24 USB sensors, if you combine this into the 4 zones, it is much easier to connect them in a short way and to use a connection between the zonal controllers and the superbrains or the central compute with only Ethernet. That's its reduction coming from.
How far you will go down, you think? I mean, how much further? I mean, if I look at Rivian is promoting like 7 ECUs and the last generation had 14. And I think sometimes, is it possible to do it incrementally, or you think you have to do a reset? Or
That's a good point. That's a good point. And let's have a look on the serviceability of the cars. You need to be, as a so-called legal or more or less heritage brand, you need to take care about the older generations of cars as well. So that's why this needs to be taken into account. A lot of new players that can provide easy solutions with one superbrain, for instance. But it is, and we all here are more or less related to software. Software reuse is an important point as well. It's not only about hardware. Now, if you wanted to reuse the software as well, you need to rely on some hardware solutions as well. So you can scale for a certain point, but it makes economically sometimes no sense to totally reset your system. That's why we rely on architectural approaches from the past. We evolutionary develop them. And then this brings us to a more high integration in the future. For sure, we see with a lot of OEM announcements, there will be a trend for more high integration. We see nowadays IVI and ADAS in one box. Then we will have maybe the body control in the box as well, maybe drivetrain controls like we see with other competitors. So for us, it is an optimum between what we developed so far, the basis we have, especially reusing software, and a clear turnover to a new hardware platform. This is not totally a revolution, it is evolution.
Makes sense, because we still have actually time. And we have a lot of suppliers in the room, and we talk about software. because what I see is when you have to reduce the number of ECUs, you have to separate hardware and software. And this means that a lot of suppliers have to then just supply the software instead of the box. And how was your experience there? Was this possible? And how was what kind of bottlenecks and solutions you see for this that really suppliers can contribute to your architecture and to your success?
To make that clear, we still rely on partner solutions, on supplier solutions for a lot of components. When I talk about self-developed software, it's not about the hardware. We are not a hardware developer for ECUs. We are a hardware developer in steel and iron for sure, yeah, but not for ECUs. This is where the design point comes into account. We design the central compute by our own, but the production and the collaboration is together with the supplier for sure. No, we need to ensure that software is portable. This is where this ecosystem is so important between the supplier and the OEM, and we still rely on that. And that's why I mentioned we need to grow together, especially if we are talking about standardization via AUTOSAR. We need to grow together. And we still stick to AUTOSAR solutions, common platforms and software, and this brings us to an ideal collaboration with hardware partners as well.
Thank you very much.